Class 8 Science, Chemistry, Chapter Metals and Nonmetals. Introduction, Physical Properties of Metals and Nonmetals. Look at these pictures. Mom, what you are using to wrap my burger? This is a foil made up of aluminium. Doctor, what is this liquid inside the thermometer? The liquid inside the thermometer is mercury. Mom, why is your ring shining so much? The ring is shining so much as it is made of diamond. Introduction. Elements can be classified into two categories: metals and nonmetals. In the previous slide, we studied substances such as aluminium, mercury, and diamond. Aluminium and mercury are examples of metals. Diamond is an example of nonmetal. Physical properties of metals and nonmetals. Metals and nonmetals. The physical properties are the physical state, luster, malleability, and ductility, hardness, color, thermal conductivity, electrical conductivity, sonority. The questions: how elements are classified? Give two examples of metals and non-metals each. Students, all of you should write this question and the answers in your copy. Let's proceed to the next slide. You are given following materials. Classify them into metals and non-metals: iron, coal, sulfur, aluminium, and copper. So these are the questions that you should answer in your copy. Physical state and luster. Physical state. Almost all metals are solids at room temperature, like gold, silver, copper, aluminium. Some of the metals to occur in a liquid state at room temperature are, are the only metals known to occur in a liquid state at room temperature, like mercury, gallium, francium, caesium, rubidium. Almost all nonmetals are solids or gases at room temperature. Graphite, diamond, chlorine, nitrogen, iodine. Exception: bromine is the only nonmetal that exists as a liquid at room temperature. Luster. Glitter or shiny surface is a property of most metals. This is because metals can be polished. This property is called luster. Because of their ability to shine and reflect light, metals like gold, silver, and platinum are used for making jewelry and other decorative articles. Almost all nonmetals have a dull surface, as most of them occur as powder and gases. They cannot be polished like metals, like sulfur, carbon, phosphorus, chlorine. Exception: graphite and iodine do show some luster. Questions. Students, again, you will need to write the questions and the answers in your copy. Number 1. Name one non-metal that occurs in liquid state. Name one non-metal which has luster. Name one metal that occurs in liquid state. Color and malleability. Color. Most metals are white or silvery gray. Exceptions are gold is yellow and copper is reddish brown. Malleability. Most metals can be beaten into thin sheets or foils. The property by virtue of which metals can be beaten into thin sheets is called malleability. Gold and silver are the most malleable metals known. This is what helps jewelry designers create intricately curved bangles, chains, and decorative articles in gold and silver. Other metals that can be beaten into sheets include aluminium, iron, copper, and tin. Non-metals are brittle and cannot be beaten into sheets or foils. Activity 1. Aim to show that metals are malleable and non-metals are brittle. Take a small iron nail. Beat the iron nail with a hammer. Try to hit hard and hit hard. Iron nail flattened upon beating hard. Activity 2. Take the piece of thick aluminium sheet. Beat the aluminium sheet with a hammer. Aluminium sheet flattened upon beating hard. Activity 3. Take piece of pencil lead made up of graphite. Beat the pencil lead with a hammer. Pencil lead powders on beating. Observation: metal objects get flattened upon hammering while non-metals break. Conclusion: metals are malleable whereas non-metals are brittle. The questions you need to write the answers in your copy. Question number 1. What is malleability? Name the most malleable metals. Question 2. Have you ever seen a blacksmith beating the iron piece? Do you find a change in the shape of these pieces on beating? Would you expect a similar change in woodlock on beating? Next properties: color, hardness, and ductility. Color. Some nonmetals are colorless while some are colored. Chlorine is a greenish yellow gas. Bromine is a brown liquid. Iodine is a violet solid. Nitrogen is a colorless gas. Hardness. Most metals are hard. Metals like sodium and potassium are so soft that they can be cut using a knife. Non-metals are generally soft. Diamond is an exception. It is the hardest substance known. Ductility. Most metals can easily be drawn into thin wires which have a wide range of applications. The property by virtue of which metals can be drawn into thin wires is called ductility. Gold and silver are two of the most ductile metals known. Other metals that can be drawn into wires include copper, aluminium, and tungsten. Have you seen wires of coal? No, definitely not. Non-metals are brittle and cannot be drawn into wires. Now, again, students, you should write the questions and the answers in your copy. Now, follow the questions. Question number 1: name the property of the metals by virtue of which it can be drawn into wires. Name the two metals which can be cut with a knife. Next properties: thermal conductivity, electrical conductivity, sonority, comparison between metals and non-metals. Thermal conductivity. Can you hold a hot metallic pan which is without a plastic or a wooden handle? Perhaps not. Metals are good conductors of heat. Metals are used for making cooking utensils. Silver is the best conductor of heat, followed by copper. Non-metals are generally poor conductors of heat. Electrical conductivity. Activity. Aim: to show that metals and graphite are good conductors of electricity and other non-metals are poor conductors. Set up the apparatus as shown in the figure. Connect the two free ends A and B of the copper wire to a iron nail. Connect the two free ends A and B of the copper wire to a graphite rod. Connect the two free ends A and B of the copper wire to a charcoal. Observation: the bulb glows when metals and graphite are connected to the free ends of the copper wire, but not for other nonmetals. Conclusion: metals and graphite are good conductors of electricity, whereas nonmetals are poor conductors. Sonority. When metal pipes strike each other, they produce a ringing sound. The property by virtue of which metal objects produce a ringing sound when struck with a hard object is called sonority. Objects like wind chimes and bells make use of this property of metals. Non-metals produce a dull sound when struck with a hard object. Distinguish between metals and non-metals. Metals have a luster, non-metals do not have luster. Metals are malleable, non-metals are not malleable. Metals are ductile, non-metals are not ductile. Metals are good conductors of heat and electricity. Non-metals are poor conductors of heat and electricity. At normal temperature, metals are the solid state. Exception is mercury. At normal temperature, non-metals are in the solid or gaseous state. Exception bromine. Ordinarily, metals have high densities and ordinarily non-metals have low densities. Metals are sonorous, non-metals are non-sonorous. Now again, the questions, you need to write the answers in your copy. So let us follow the questions. Question number 1. Write the differences between metals and non-metals on the basis of their physical properties. Question number 2. Why cannot you have wooden bells? Question number 3. Non-metals do not conduct heat or electricity except one. Name of the non-metal. Chemical properties of metals and non-metals. Reaction with oxygen. Chemical properties of metals and non-metals. Point number 1. Reaction with oxygen. Reaction with 2. Water. Point number 3. Reaction with acids. Point number 4. Reaction with bases. Point number 5. Displacement reactions. Reaction with oxygen. Most metals combine with oxygen to form metal oxides. Metal plus oxygen is equal to metal oxide. Sodium reacts vigorously with the oxygen present in air to form sodium oxide. Na, that is sodium plus oxygen O2 is equal to Na2O. So that is sodium oxide. Now to balance that, we need to put before that is 2 Na2O. And 4 before that Na, that is sodium. Sodium catches fire if left in open. It is therefore kept immersed in kerosene. Activity. Aim. To synthesize a metallic oxide and test its solution using litmus paper. Hold a magnesium dibond with a pair of tongs and ignite it. Magnesium ribbon burns with a bright white light and forms a white powder. Magnesium, on heating, burns in air, that is oxygen, with a dazzling white light to form magnesium oxide. Mg, that is magnesium, plus O2 oxygen, MgO, magnesium oxide. So after balancing, 2 Mg plus O2 equal to 2 MgO. Activity: collect white colored magnesium oxide powder. Take spoonful of magnesium oxide and dissolve in water. Dip a strip of red litmus paper in the solution. The red litmus turns blue, indicating that the solution is alkaline. This happens because magnesium oxide dissolves in water to form magnesium hydroxide, which is an alkali, and turns red litmus blue. MgO, that is magnesium oxide in solid form, plus H2O, water, that is in liquid form, gives you MgOH2, that is magnesium hydroxide. Conclusion: metal react with oxygen to form metallic oxides, which are basic in nature. Non-metals like carbon, sulfur, and phosphorus react with oxygen to form non-metallic oxides. Non-metal plus oxygen gives you non-metallic oxide. These oxides are also called acidic oxides as they form acids when dissolved in water. Carbon burns in air or oxygen to form carbon dioxide. C, that is carbon, plus O2, that is oxygen, gives you CO2, that is carbon dioxide. Carbon dioxide dissolves in water to form carbonic acid. CO2, carbon dioxide, plus H2O, water, H2CO3, that is the carbonic acid. Now look at the questions and answers in your notebook. Question number 1. What happens when a metal reacts with oxygen? Question number 2. Give a balanced chemical equation when magnesium reacts with oxygen. Question number 3. Why is sodium stored in kerosene? Reaction with oxygen. Sulfur burns in air or oxygen to form a pungent, that is having a strong smell, suffocating gas called sulfur dioxide. Is sulfur plus O2 oxygen, that is SO2, sulfur dioxide. Sulfur dioxide dissolve in hot water to form sulfurous acid. SO2 sulfur dioxide plus H2O water, H2SO3, that is sulfurous acid. Aim: to synthesize a non-metallic oxide and test its solution using litmus paper. Activity: take a small piece of charcoal, a form of carbon, in a deflagrating spoon and ignite it. Put the spoon in a glass jar and cover it. Remove the spoon from the jar after some time. The jar will be filled with carbon dioxide gas. C carbon plus O2 oxygen gives you CO2 carbon dioxide. Add some water in the jar and cover it again. CO2 carbon dioxide plus H2O water gives you H2CO3 carbonic acid. Taste a solution with blue litmus paper. Blue litmus paper turns red, indicating that the solution is acidic. Conclusion: the nonmetals react with oxygen to form nonmetallic oxides which are acidic in nature. Questions. Question number 1. Write a balanced chemical equation when sulfur dioxide is dissolved in water. Question number 2. What is the effect of sulfurous acid on blue litmus? Question number 3. Explain the reaction of nonmetals with oxygen with the help of an activity. Reactivity series: reaction with water. Reactivity series: Ka potassium, Na sodium, Ca calcium, Mg magnesium, Al aluminium, Zn zinc, Fe iron, Pb lead, Cu copper, Hg mercury, Ag silver, Au gold. These are given in the decreasing order. As we move down, reactivity decreases. K is most reactive, gold is less reactive. The arrangement of metals in the decreasing order of their reactivity in the form of series is called the reactivity series of the metal. Reaction with water. Most metals react with water to produce a metal hydroxide or metal oxide and hydrogen gas. Metal plus water gives you metal hydroxide plus hydrogen gas. Metals like sodium, potassium, magnesium, zinc. Reaction of metals with water depends upon reactivity series. Sodium and potassium metals are so highly reactive that they catch fire on coming in contact with water. Therefore, they are stored under kerosene. 2Na plus H2O, 2H2O is equal to 2NaOH, that is sodium hydroxide, plus H2 hydrogen gas. Sodium reacts with cold water to form sodium hydroxide along with hydrogen gas. Aim: to show that magnesium reacts with water to form magnesium hydroxide along with hydrogen gas. Activity: take two test tubes, take a piece of magnesium ribbon, fill test tube half with water, gently warm the test tube over the flame of a Bunsen burner. Observe carefully. You will observe the evolution of a gas in the form of bubbles. It burns with a cracking sound. This happens because magnesium reacts with water on heating and liberates hydrogen gas, which burns with a popping sound. Now bring a burning splinter near the mouth of the test tube. Conclusion: magnesium reacts with water to form magnesium hydroxide along with hydrogen gas. Questions: copper cannot be displaced zinc from its salt solution. Give reason. This is question number 1. Question number 2. Arrange the following metals in the order of their decreasing chemical activity: magnesium, potassium, iron, gold. Reaction with metal with water, reaction of non-metal with water, reaction with acid. Reaction of metals with water. Metals differ in the reactivity towards water. Metal potassium, sodium, reaction condition cold. Metal calcium, magnesium, reaction condition hot. Metal aluminium, zinc, iron, lead, reaction condition steam. Metal copper, mercury, silver, gold, platinum, reaction condition there is no reaction. Non-metals do not react with water. Therefore, some reactive non-metals are stored in water to prevent their reaction with air. For example, phosphorus is kept in water to prevent its contact with air. As it catches fire on reaction with air. Reaction with acid. When a metal reacts with an acid, a salt and hydrogen gas are produced. Zinc reacts with sulfuric acid to form zinc sulfate and hydrogen gas. So zinc Zn plus sulfuric acid H2SO4 gives you ZnSO4, that is zinc sulfate, plus H2, that is hydrogen gas. Magnesium reacts with sulfuric acid to form magnesium sulfate and hydrogen gas. So, Mg magnesium plus H2SO4 sulfuric acid gives you MgSO4 magnesium sulfate plus H2 hydrogen gas. Aluminium reacts with hydrochloric acid to form aluminium chloride and hydrogen gas. So 2 aluminium Al plus 6 HCl hydrochloric acid gives you 2 AlCl3, that is aluminum chloride, plus 3H2, that is hydrogen gas. Aim to show that hydrogen is produced when magnesium reacts with dilute sulfuric acid. Activity: take a piece of magnesium ribbon in the test tube. Using a dropper carefully and a few drops of dilute sulfuric acid. Bring a burning matchsticks near the mouth of the test tube. Conclusion: the gas produced in the reaction is hydrogen. Questions. Question 1. Some non-metals like phosphorus are kept in water to protect them from the atmospheric oxygen. State the property of the non-metals utilized here. Question number 2. What happens when a metal reacts with acids? Reaction with acid, reaction with bases, displacement reaction, comparing reactivity of metals. Reaction with acid. Non-metals generally do not react with acids. Some non-metals like sulfur and phosphorus react with hot concentrated sulfuric acid and nitric acid, but they do not liberate hydrogen gas. Why pickle is stored in earthen pot? Certain foodstuffs like citrus fruits, curd, pickle, tamarind, etc. contain acid. Reaction with bases. Most metals do not react with bases. Only a few, like aluminium, zinc, and lead, react with solution of strong bases like sodium hydroxide to produce a compound of that metal and hydrogen gas. The reactions of nonmetals with bases are complex. Displacement reaction. It is a chemical reaction which takes place when an element or radical has replaced another element in a compound. The representation is like x plus yz is equal to y plus xz. More electropositive metal displaces the less electropositive metal. Zinc plus CuSO4 is equal to ZnSO4 plus Cu. Metals: K, Na, Ca, Mg, Al, zinc, Fe, Pb, H, Cu, Hg, Ag, Pt, Au. The metal which is replaced higher in the reactivity series is more reactive than those placed below it. You can predict whether or not a displacement reaction will take place by looking at the activity series. A metal will only react with a salt solution if it is placed higher in the activity series than the metal in the salt. Zinc, being more reactive, displaces copper from its solution. Silver doesn't react with zinc sulfate. Ag, that is silver, plus ZnSO4, that is zinc sulfate, no reaction. Silver doesn't react with copper sulfate. Ag plus CuSO4, no reaction. Silver is placed lower in the activity series than zinc, and copper, hence, it is less reactive and does not displaces zinc and copper. From the above reactions, we can conclude that the order of reactivity of zinc, copper, and silver is Zn greater than Cu greater than Ag. That is, zinc is the most reactive of the three, and silver is the least reactive. Comparing reactivity of metals. Activity. Aim. To prove that iron is more reactive than copper. Take two test tubes. Take some iron fillings in a test tube A. Take some copper turnings in a test tube B. Add copper sulfate solution in a test tube A and iron sulfate solution in a test tube B with the help of a dropper. In test tube A, iron filling turns brown due to the deposition of copper. The solution turns pale green due to the formation of iron sulfate. And in test tube B, no reaction is observed. Conclusion: iron is more reactive than copper as it displaces copper from copper sulfate solution. Questions. Question number 1. Can you store lemon pickle in an aluminium utensil? Explain. Question number 2. Name the metals which reacts with bases. Question number 3. Give one example of displacement reaction. Question number 4. What happens when iron nails are placed in copper sulfate solution? Write word equation for the reaction. Corrosion. What is the reason behind this corrosion? The process of slow eating away of a metal due to the attack of atmospheric gases and moisture on its surface is called corrosion. Iron reacts with oxygen and moisture present in the atmosphere to form brown, flaky substance called rust. Rusting of iron is undesirable reaction because a layer of rust formed falls off, exposing the metal to a further rusting. Iron objects become weak with the passage of time. Copper objects get coated with a green substance called copper carbonate with the passage of time. This green substance is formed due to the reaction of copper with carbon dioxide and moisture present in the atmosphere. Silver objects become blackened and lose their shining with the passage of time. This happens due to the reaction of silver with hydrogen sulfide gas present in the atmosphere. Questions. Question number 1. What is corrosion? Question number 2. What are the conditions for rusting? Question number 3. Silver doesn't combine easily with oxygen, but silver jewelry tarnishes after some time. Why? Noble metals. Uses of common metals. Noble metals. As seen from the reactivity series, platinum is the least reactive metal. It does not react with air, water, acids, bases, and most other substances. Another metal which shows similar behavior is gold. Gold and platinum are called noble metals. Since noble metals are less reactive, they are not chemically affected by the substances around them. Hence, they do not get tarnished and retain their luster for a longer time. Pure gold is very soft, therefore, it cannot be used for making jewelry in this form. For this purpose, it is mixed with silver or copper to make it hard. The purity of gold is expressed in terms of carats or carats. A carat means the number of parts of gold present in 24 parts of the mixture of gold and other metals. For example, 22 carat gold means 22 parts gold is present in 24 parts mixture of gold with copper or silver. This implies pure gold is 24 carats. Uses of common metals. Metals have been an integral part of our daily life since ancient times. They have played an important part in the development of various civilizations. The most commonly used metals in everyday life are iron, copper, aluminium, and silver. Questions. Question number 1. Name the noble metals. Question number 2. Write the usage of metals. Question number 3. Why copper is added in making gold jewelry? Uses of common metals. Iron is used for making cooking vessels, water boilers, toys, tools, pipes, stoves, agricultural implements, chains, wires, electromagnets, nails. Aluminium, being a very light metal, is used for making aircraft bodies. It is also used for making vessels and thin foils, which are used for packaging of foodstuffs and medicines. Copper is the most widely used for making electrical cables and other electrical goods. It is also used for making cooking utensils. Silver is used for making jewelry, decoration pieces, tableware, foodstuffs. Questions. Question number 1. Write the uses of iron. Question number 2. Aluminium is used for making aircraft bodies. Give reason. Question number 3. Write the common uses of copper and silver. Uses of alloy, composition and uses of alloys. Uses of alloys. Besides being used in their pure form, metals can also be used in the form of alloys. An alloy is a homogeneous mixture of two or more metals or a metal and a nonmetal. By adding appropriate amount of other metals or non-metals, that is by forming alloys, the properties of a metal can be modified. Alloy are generally stronger and harder and are resistant to corrosion. Composition and usage of alloys. Steel is used in construction material machine parts. So iron plus chromium gives you nickel, plus nickel gives you stainless steel. So iron plus chromium plus nickel gives you stainless steel. Stainless steel is used for making cooking utensils and surgical implements. Copper plus zinc gives you brush. Brass is used in making utensils and decorative statues. Questions. Question number 1. What are alloys? Question number 2. Write the composition and uses of stainless steel. Question number 3. Name the alloy used in making utensils and statues. Composition and uses of alloys. Uses of non-metal. Composition and uses of alloys. Copper plus tin gives you bronze. Bronze is used for making coins, medals, and statues. Copper plus zinc plus nickel gives us German silver, that is used for making tableware. Aluminium plus Copper plus magnesium plus manganese gives us duralumin. Duralumin is used for making aircraft bodies, automobile parts. Aluminium plus nickel plus cobalt gives us alnico. Alnico is used for making magnets. Copper plus tin plus zinc gives us gunmetal. Gunmetal is used for making gun barrels. Usage of nonmetals. Nitrogen in the form of fertilizers is essential for the growth and development of seeds and plants. Phosphorus is used in matchbox industry and in fertilizers. Iodine is used as an antiseptic. Sulfur is used for making firecrackers, gunpowder, and sulfuric acid. Oxygen is essential for all living beings. Diamond is used for making jewelry and in cutting and grinding tools. Graphite is used in batteries and in pencils. Questions. Question number 1. Write the composition of bronze, German silver, gunmetal, alnico, and duralumin. Question number 2. Write the usage of bronze, German silver, gunmetal, alnico, and duralumin. Question number 3. Write the usage of nonmetals. Question number 4. Name the nonmetal used as an antiseptic. Thank you. Please subscribe to my channel to get more updated videos on different topics.